Well, hello friends. Today we are going to make the Serenity browser load a page over HTTP. So that's going to be quite exciting. And the first thing we're going to do is just edit the welcome page here and add a little URL. Not HTTPS because we don't support that, but we'll put serenityos.org. Because I recently purchased that domain name using some of the money that was very generously donated to me on Patreon. So thank you. Huge thank you to all the Patreon supporters allowing me to buy a domain name for the project. Okay, so and then let's just verify that it looks right. I mean, obviously it's not going to load, but just want to see that we're on the right track. Get a refresher on what the browser looks like. Okay, so here it is. Click on that, and well, we don't really go to the right place because we don't know how to load that thing. But we are here in HTML view load. We can see that this debug print statement here. Let me just make it a little bit bigger. Shows the right thing. So we print out the URL we're going to load, and then we fire callback, like one of these hooks that we have, and then we immediately just assume that it's a local file and try to open it. So this has to work a bit differently for HTTP, obviously. So I think what we're going to do is we're going to make like a resource loader kind of thing, and it'll just be a thing like a black box that you can give a URL, and eventually it will give you back the data for the URL. Like just to start with, we'll do something like that. So we'll call it resource loader, I guess. And let me add that to the make file. Resource loader. Okay. Let me refresh my cube creator. Okay, and then I think the way I would like to use this is maybe we'll let it be a singleton right now. So we'll just do something like this, and then we'll say load URL, and then we'll make a callback. And it will give us the data as a byte buffer, I think. So data, and we'll just make it very, very simple right now. So data, and then if if it's failed, then we'll just give you a null byte buffer. Let's say load failed, and actually let's just capture this here. Load failed. Okay, not terribly exciting, but whatever. Return. Actually, let's assert not reached so that we crash and we can look at it. But if we do get the data, then we basically want to continue. So this is like the part that reads the local file, right? And then this is the part that has all the HTML, and now it reads it. So this is what we want to do in the callback. Something like that. And this is the data, and and we're going to need the URL actually. So let's just capture it. Okay. That's good. We could even do a value capture, actually. Okay, great. And then we can start to flesh out this resource loader thing based on this. So, class resource loader. For now, it's just going to be a simple singleton. So we'll have a static resource loader, and we'll have a private constructor, and let's see. We want we're going to need act function actually. And then we're going to want let's just have it return void for now. This thing is going to be fleshed out and more sophisticated later, but right now we're just going to do it very, actually let me include that just so that I get the right definition. Earl and a callback that gives you the data. I think that's pretty good. Okay, so let's make sure that we include this. Oops, that doesn't say include at all. Resource loader, all right. And then in resource loader.cpp, we will put the, obviously, no, not the empty constructor. That was in the header, but we wanted this, the function. If the esta is near resource loader. Static resource loader as the. Okay, returns the. Great. We have invented ourselves a lazily allocated singleton object. Beautiful. I should probably make a class that does this for me, but I've been lazy about it. Okay, so let's implement the load function. So I guess first things first, we can just have it handle file URLs, because we're going to send file URLs and HTTP URLs and any kind of URL through the same function. Like that's kind of the point, so that we have a unified path for loading. Because if you have like if you branch on like the protocol everywhere, then shit's going to get really messy. So it's better if you have a single point where you handle the different protocols, and then you give like symmetric callbacks, basically, or like the same kind of callbacks for each protocol, to the extent that it's possible. Okay, so we want the URL and a function object. Callback. Okay, and now we're going to do this thing here where if like URL.protocol is file, then we can do this fancy thing. So we'll grab libcore C file, and just data is callback data. And here, instead of return, we'll do callback null buffer, or callback empty byte buffer, which you would write this way. Okay, so this is just if we fail to open that file name. Return if URL protocol is HTTP serve not reached, like unimplemented protocol, URL protocol. Okay. And if we get an HTTP, then we're going to need some help from libcore. CHTTP request, and CHTTP job. I think those are the classes. I haven't used this for a while, like I was saying. But basically the idea is that you create a HTTP request, and then you set URL to the URL, and set method is HTTP request method get, because we want to get this URL. And what else is on there? set URL, set method, and then we just have to schedule it. Okay, well that sounds really simple. Auto job is schedule. So this should give us a CHTTP job object or a CNetwork job pointer, but it actually contains a CHTTP job. And CHTTP job will just go in the background and do the network request to the server, and it will handle like incoming data. And then when it's actually gotten some data, then let's see how that's implemented. HTTP job, network job. Is that the one that we want? On finish, that's the thing that we want to look at. So we get on finish, and if we get success, then we can extract the network response here, which will contain a payload. So that's how we're going to get to the data that we're interested in. So let me actually see here. Let's open resource loader. Okay, so the fact that this is scheduled here, it doesn't mean that it will return right away. So these jobs are always asynchronous. So after you create a job, it's not going to finish before you return to the event loop. It's not going to synchronously finish here. So we are free to set up a callback without worrying that like it would finish between the call to schedule and setting up the callback. So we're going to do this, and then we'll say auto. Oh wait, it's going to give us the bool success, right? If not success, HTTP job failed. We'll just say that much and crash. Okay. And then, let's see, what was the thing? So this is on finish, right? And then we have bool success, so now it's true. Then we should be able to extract the response. So response is maybe I think it should always be a response here if you succeeded. So response is job. Oh, can I get the job actually? I would have to capture job. Okay, okay, we can do that. We'll just capture it like this for now. We want job response. Maybe we don't even need this. We're gonna need callback though. Okay, well we'll work this out. Let's see. Callback is move callback. Okay, now we have callback with us. Maybe we don't need this. Okay. We can do this as well. We'll just move these with us. This is kind of an awkward syntax. Like I wish there was I wish there were a way to like move everything with us, because there's like capture by value, capture by reference. But is there a way to like capture by moving everything? Because like this is the last thing I'm going to do in this function, so I don't need these things anymore, and I just want to move them to be owned by this lambda right here. Anyways, this syntax is clunky, but it does what I want. So we'll assert response, and then I guess the payload is this, the response payload. We can probably just call the callback actually like this. So let's try that. Callback response payload. Oh, do we need to include something for this to work? Yep. Libcore CNetwork response. Oh, and is that like a CHTTP response actually? Yeah. So it's actually one of these, and we could look at the headers in the response and the HTTP status code and stuff, but we don't need any of that for this purpose. We just care about the payload. So I think maybe this is everything that we need. So let me just see how this is implemented. When we call onFinish. So when we invoke onFinish in either did fail or did finish in CNetwork job, then after that we call shutdown, which tears everything down. Right. So notice here that I create this job and I schedule the job, and then I immediately pass ownership of the job to the Lambda here. So there's nothing else keeping the job alive except the fact that it's captured. And then when this thing finishes, and we invoke onFinish from the network job class, then we'll call shutdown, which I think is supposed to clear the onFinish, but maybe it doesn't actually. Onfinished is equal, no, onFinish. So maybe this leaks actually. Well, we need to work that out at some point, but right now let's just see if we can get the whole thing working. All right, come here, browser. All right, so file URLs, definitely loading. What about an HTTP URL? Ah, we crashed. Assertion failed on finish. And see, here is me talking out of my ass, apparently. Because I was saying how it's safe to set up on finish after you schedule. But then looky here. In the call to schedule, it calls to start and then it fails immediately. Before I have a chance to set up onFinish, and then it asserts because we didn't set up onFinish. So that's not right. Why is it failing immediately? So this fails right here. So this should be a deferred invocation to did fail. So we're gonna just wrap that in deferred invoke, which is a very handy libcore mechanism that just allows us to execute something on the next time we get to the event loop. No, it doesn't need double parens. Yeah, just like that. It's pretty handy. So just because then the thing I was saying before actually becomes true. Of course, it's interesting to figure out why connect fails. So I guess we'll be able to look at the error output when we click here, and oh, things fell apart big time. It's some unrelated Windows Server problem. But where is the browser crash? Resource loader load. Then we're asserting it's CNetwork job. Okay, so resource loader load. The assertion is I'm doing like operator arrow on a ref putter that is null. And the ref putter T, where T is CNetwork job. So we know that it's a ref putter to a CNetwork job. And I'm in resource loader load. So is it this one? Oh, maybe this actually, maybe the capture happens before. Oh, this is something I never thought of. Like if you're capturing something that you're also dereferencing in the same statement, maybe that's not That's probably not cool. Fine, let's just capture it by value. It doesn't matter. Maybe capture everything by moving it would be very confusing in a situation like this, actually. Okay. Ah! Look at that shit. This is indeed the tiny web page that I made and I put there, and we just loaded it. Let me show you. Here it is in Firefox, and here it is in Serenity. This is actually the first time we ever loaded a web page from the real-life World Wide Web. And that's pretty cool. Okay, I gotta try something. I gotta try loading Roger Clark's cyberweb page. So Roger Clark is he's a guy making videos about development on Windows 2000, and they're super fascinating. And he started making like a 90s browser on Windows 2000 using era appropriate tools, and his browser's called Cyberweb. And he has, I think it was cyberweb.surf is his webpage that he wants to test. So I gotta test this to see if it loads. Ah, shit. Oh. HTML image loaded. Oh, because we don't support this in HTML image. But maybe we can fix that. Because I would love to load his website. Let's see. So image loading has hard-coded handling of file protocol, and then it doesn't know what to do with anything else. So who calls load image? So when we parse the attribute. So I guess we could do something very similar here, where we just use the resource loader. This will be kind of clunky, but we'll just do something like resource loader load source URL data, and then bitmap is, or wait, hold on, if data is null, we'll say, oh wait, I have to do the failed to load. I guess we can just dump out the source. Do we have the source? Well, we gotta capture something. It doesn't provide a call operator. Oh, but I don't want to capture it like that because it's on the stack. And okay, let me just capture this. And it's kind of weird because, like, wait, isn't this a bug? Like, if I captured this, then source inside of the lambda should not refer to this argument here, but rather the src function, or member function in HTML image element. I feel like that's not right, but I'm not 100% sure because I'm not a C++ correctness wizard. It's just a tool that I try to be good at using. So I'm going to be lazy and do it this way, and then we'll get around the problem for now. And actually, maybe we'll just tolerate this situation. And if we do manage to load it, we'll say mbitmap is graphics bitmap load from file. But I don't want to load from a file. Can I load from something else? Mapped file, blah, blah, blah. I want load PNG. Oh, load PNG from memory. That's what I want. Okay. So I only support PNGs, so I hope cyberweb.info has a PNG, but we might just fail to load it, which would be okay. It's probably actually not going to have a PNG, because it wouldn't be very 90s. But we'll see when we try to load. See if we can try to load this, see what happens. So load PNG from memory, data.data, data.size. Okay, and then if mbitmap, then this document, or maybe just document, and validate layout. Okay, it would be cool if this just worked. Oh, wait, why did it crash now? Start, did fail. Oh shit, I'm not actually rebuilding libcore. The incremental build system bites me once again. So I guess sometimes we just fail to load for some reason, maybe DNS lookup fails or whatever. I bet if I look in the log, I can see what the error is. Found. Well, that didn't go entirely right. Name cheap URL forward. Do I have to do this? Okay, well, we're here. So, come on, load. Ah, damn it. What's wrong this time? Resource loader load. Unable to resolve empty. Okay. Let me see. No, it's just not gonna work. Well, what's wrong with it? Oh, wait, hold on. Something was very wrong with the URL. Why does it think that this is the URL? That doesn't even make any sense. Okay. Dude! That's so cool. Oh man, so I guess we failed to load the image because there's supposed to be an image here. But we got a lot of it right. Oh man, it's so awesome. So shout outs again to Roger Clark, who's building a 90s browser. And definitely check that out at cyberweb.surf, which we now almost completely rendered. Oh, I forgot to see what that image was. I bet you that it's a GIF or a JPEG. A GIF or a JPEG. GIF, JPEG. It's a JPEG. Look at that. Okay. So, yep. Well, I'm not going to implement a JPEG decoder right now, but hello, CyberWeb. That's awesome. This is a bit glitchy. I don't know why this is happening. Maybe it's just something that goes wrong and it doesn't like that I'm using I'm not using dub, because with dub it works. Maybe I just didn't configure the DNS in the best way. So let me tweak this to just say www here for now. And let's also actually see that the images test still works. Yeah, so that these images are now loaded through the resource loader class, which is really cool because it's now able to load file URLs and HTTP URLs. So cool. Okay, so let's see what we have ended up with. Guess we can, oh, maybe we should fix this thing first of all. Cached. Wait, forgot what it was about. Right, so previously we would fail synchronously in CHTTP job start if the socket failed to connect. But if the socket fails to connect, it will now fail asynchronously. Libcore CHTTP job start should fail asynchronously. Clients are expected to have a chance to set up an on-finish callback before we finish or fail. Finish or fail. Okay. And then that's really neat. We should have a graphics bitmap load from memory, but right now PNG is the only format that we support, so we'll get there. But for now, this will do. So let's just add these. And oh, wait, hold on. Let me see what this patch is actually doing. So here we're adding a link to the very fancy serenityos.org. Okay, and then in the image element, instead of trying to open it as a local file, we now use the resource loader to load the URL, and then when we get the callback containing the data, we try to load it, and if it actually loads, then we won't invalidate the layout. It's pretty cool. Actually, we should always invalidate the layout, I think, because if it fails or if it succeeds or fails to decode, we should still update the layout so that it reflects the state of the bitmap loading or whatever. Okay. Then in HTML view, we now also use the resource loader in HTML view load. And yeah, if it fails, then we should just print out load failed. And there are failures, and I know that DNS resolution can be very flaky. It's something that needs to be robustified, like it needs a cache, it needs a retry mechanism, it needs whatever. But you could see that it worked a little bit, and it's pretty exciting. Okay, so then here we just took what we did before, which we did synchronously after loading the file, and now we just do it in a callback that we pass to resource loader. Very, very simple. And then in resource loader, if the incoming URL is a file, then we just open it right away and invoke the callback right away. So we could do something here where we use the deferred invoke to always make the callbacks asynchronous. That way we would never have synchronous callbacks, and they would be consistent. I suspect that would probably be a good idea, because otherwise we might end up with like slightly inconsistent behavior between file URLs and HTTP URLs. So I think I'm just going to do that. Deferred invoke. Oh wait, how the heck do we do that? C object deferred invoke. Is this static? No, I need a C object in order to do this. Ew. I need a C object. Well, okay, then let me commit this and then we'll do that in a separate patch. But basically, the HTTP implementation is just create the HTTP request, schedule it so that we get a job, and then set up an onFinish callback. And in here, we just grab the response and invoke the callback with the payload. And that's it. And here's the very, very modest resource loader header. Okay, cool. Add resource loader to abstract or protocol agnostic URL loading. Initially, this now support loading both file and HTTP URLs. Feel free to visit OS.org and enjoy the fancy good times. Heck yeah. Okay, and then I wanted to do a deferred invoke so that this becomes asynchronous. So I'm just going to turn this into a C object. Source loader. Okay. And that means that this has to work a little bit differently, but not terribly differently. Just have to call resource loader construct.leadgraph. Oops. It's a bit unusual to have a C object singleton, but it works. Just make it this way. Okay. And then now we should have access to, not here, here. Deferred invoke. Data. Oh, we'll bring that with us. Oh shit, and we have to bring the callback with us as well. Callback, move callback. Okay, so now file URLs should be asynchronously handled in response to the load finishing, even though like it was a local file all along. So let's try that with those images. Ah, still works. I mean, oh wait, hold on, what's it saying here? Message file. Oh, right. But see, these are bad URLs down here, so that's why we're seeing some failures to load. HTML view load, message file directory, what? Wait. Oh, shit. Right, this shouldn't be here. This debug message is wrong. Resource loader. Okay. So, get status if. That's great. Loop HTML. Fire the file. Load completion callbacks asynchronous. This makes it consistent with how HTTP callbacks are fired. It would probably be fine to have file be synchronous but at the same time, it seems it's nice to have consistency. Okay, so this is very, very cool. I gotta try this one more time. It failed. Okay, so why does it fail now? Unable to resolve SerenityOS.org. Why is that failing? Do we actually ask the lookup server? Unable to resolve. Broken pipe. Why are we getting a broken pipe? So we definitely have a lookup server running, but I feel like it didn't even give it a chance to do anything. Okay, so this is probably just an intermittent problem, I hope. Yeah, okay, so it's just probably just some bug in the DNS implementation that I need to look at, but I'm not going to work on that today. Today was just about loading over HTTP, which now basically works. How cool is that? Welcome to the future home of Serenity OS. I think that's going to be it for today's video. So if you made it this far, then I thank you for watching, for hanging out. And these are fun times. Who knows how far this will go, and what we'll make of it. But if you stick around, you'll find out, I guess. So thanks for hanging out. I'll see you next time. Bye.